Hi, this is LUKEZ with the second tutorial of how to create a simple breakout game with Unity. So, in the first tutorial, we saw how we created the petal, the block, the ball, and the walls around the border of the screen. So, in this second tutorial, we are going to do some things on the petal. First, make it move from one side to another by pressing the arrow keys. Then, make the ball attached to it, and when the space is pressed, the ball is shot upwards and bounced around. And finally, add a small sound clip to the pedal, and the final thing that we are going to do is a small addition, is to make the ball, when it hits approximately the edge or somewhere like that, it takes a bit of an angle so that it doesn't bounce back and forth at a 90 degrees angle and not hitting any blocks on the sides. So let's begin scripting. So the first thing is to open the scripts folder that we created before in the first tutorial and create a new JavaScript file and name it pedal controller. This will hold all the controls regarding the pedal. So double click it and mono develop open, which is the IDE which Unity uses so that the code can be edited. So here you will have this hashtag pragma strict, which is some codes that are strict, but we can remove it, and we should. So you will have two functions, function start and function update. Function start will be executed once the game is loaded, and the function update is executed every frame. So let's start by adding some variables. So I'm going to add these variables and then explain what they mean and what they will do. So var y position of type float is equal to 0. Copy that, paste it, and change the y to z. So var z position of type float is equal to 0. Var x boundary of type float is equal to 0. Var speed of type float is equal to 115. Var max boundary of type float is equal to 20.0. Var ball prefab of type game object, var attached ball of type game object, and is set to null. Var ball rigid body with a small b so that it is understandable, of type rigid body with a small b. Var ball speed of type float is equal to 4250. Var pedal sound of type audio clip. So let's see one after each other what they will do. So the y position will hold the y position of the pedal. So in this case, minus 85. So let me remove that so that we can do it again. Now the z position will I added a variable of z position just in case, because it is going to be always 0, as the z position of the pedal is always 0. The x boundary it's not the X position of the pedal, but is the X position of the left and right walls. That's because X boundary, because X on the X-axis and boundary, where the pedal will stop. So we have to take this value, which is of the walls. The speed is obviously the speed of the pedal. Now, max boundary means this is the X boundary, and it is calculated from the middle of the pedal. So if the pedal moves without the max boundary, it will stop once the half of it reaches this point. But we don't want that. We want to have this edge stopping right there on the X boundary. Therefore, the max boundary compensates for that half of the pedal coming out of the screen. The ball prefab will hold the ball, which is going to be attached to the pedal. Sorry. The ball prefab will be the ball once the game is started and it is going around the screen. The attached ball will hold the ball with that is attached with the pedal. The ball rigid body will be the rigid body as we added in the first tutorial to the ball while the ball is moving around the screen. That will be its rigid body. The ball speed will obviously be the speed of the ball around the screen, and the pedal sound will hold of type audio clip will hold the small sound clip that we have. So first of all, because of the sound, let's add the pedal sound as I did before. So to do that, just right click, just open the folder sounds. If you don't have one, just make it. Import new asset, and from the resource file that you have downloaded, you should find a file pedal sound. Okay, let me delete this and rename that so that I'm going to do it step by step. So you will have this pedal sound. Now the only thing we have to change about it is to untick 3D sound and choose apply. And now it is a 2D sound so that it can be used in the game. So once that's ready, we can begin scripting some code. So in the update function, we are going to make the pedal move. So I'm going to make a comment, move pedal, or pedal movement, sorry, just to remind you of what the code will mean. Movement like that. Now we can begin. So if input with a capital I dot get axis, open brackets and open inverted commas and write horizontal here with a capital H and perfectly as I have wrote it, horizontal, close and close, is not equal to 0, we are going to move the pedal. So transform dot position equals new vector 3. So what we are doing is, if the axis horizontal, which means when the pedal moves from one side to another by pressing the arrow keys, important, or A and D, one of them. Here you can see from where I got it. So project settings input right here, right, like this, input dot, now axis and horizontal. Right here you have horizontal, the name. If you change this name, you have to change this one. That's why I told you to write it exactly. These are obviously defaults of Unity, therefore you can use them. Negative button left and right that you have to press, or A and D, and some other options. So that's good, as you understood why. Now let's go again in the pedal. Now if the horizontal is not 0, therefore if it is moved, transform.position, let's move it. So the position will obviously change. So new vector 3. Vector 3 is holds three values, always 3 values of type float or integer, that will of the x-axis, x, y, and z, and we have to replace those always with values so that a new position can be transformed. So new vector 3 transform dot position. Don't worry if the IntelliSense doesn't show you any possibilities, because JavaScript is a little bit not supported when it comes to some complicated code, although this is not complicated, but it is a little bit long. Transform.position.x plus input.getAxis, and write again horizontal, so that the x-axis is always horizontal. This is the x-axis. Now we are going to times speed, so that the pedal moves at that certain speed, times time dot delta time, which increases it a bit. Now comma, we finish the x. Now comma, we need the y. So the y, we have a variable for it, and it is y position, and the z, we have also a variable for it, z position, so that we are ready. Now once that's finished, we need another thing so that the pedal can stop at the boundaries, as I said so earlier. So now in the if that we wrote this code, let's make another if statement. So if transform with a small t dot position dot x is smaller than minus the x boundary, because this will serve for both the sides, not for one side only. So here we have the minus x boundary, not x boundary only, because as we can see here, the left wall has a negative x value. So we are going to input a negative x value, and the max plus max boundary, which means that a boundary will be added with that the max boundary will be added to the x boundary, and from here it will come till somewhere here. Therefore the x boundary is here, the max boundary will increase it, and it will come till here, so that you understand it clearly. So if the boundary is over, you will the pedal cannot go beneath that value. So if transform.position.x is smaller than minus x boundary plus max boundary, then transform dot position equals new vector 3 minus the x value will be minus x boundary plus max boundary comma y position again comma z position again. Now, that will serve only for the left side. So we are going to do another one for the right side. So copy paste that and write else and paste it, because we will need an else if, so, therefore we need that. So if transform.position, and now we are going to compensate for the right side. So is bigger than the x boundary, so now it is positive, minus the max boundary, so that it caters for the other side. So the x boundary is here, and minus the max boundary, so it comes till here. So, and copy paste that, we can paste it instead of writing it, and copy paste it there. Okay, so that's ready. I think that we are ready. So the last thing to do is to go in the scripts and drag the script onto the pedal, select the pedal, and let's change some values right here as we said before. So y position, let's make it minus 85 as we have here. The z position, let's leave it to 0. The x boundary, let's make it 133, I think, yes, right wall, or 134, let's make it 134. Sorry, we only have to grab this value, so copy or change it 134. So that's ready, and now we have to drag these objects right here. So go to prefab, near the ball prefab, drag it. The attached ball is none, let's leave it none. The ball rigid body will drag the ball again, and it will take automatically the rigid body of the ball. Ball speed, let's leave it like that, and the pedal sound, we have to drag the pedal sound right here. We have to later on add something so that it plays, because right now it doesn't play. But it will give us an error if we don't add the necessary game objects and values to the variables. So let's play it, and if I press the keys right here, as you can see, the pedal moves around on the x-axis, and if I continue to press the right arrow, it will not go out of the screen, and it goes the same for the other side. So that's done. Now the next thing is to make the ball attached to the pedal. So let's begin. Let's make a new function of our own. So let's make a function called spawn ball, open close curly. Now listen carefully. So attached ball equals to, I'm going instantiate like that, ball prefab, comma, transform dot position plus new vector 3 0, 40, 0, quaternion dot identity with a small I as game object. So this line is very important. So before we declared the attached ball as none, but as a game object. That's why. But it is null, so it doesn't exist. So now we are inserting a prefab into that attached ball, into that. So we are creating a game object and putting it into the attached ball. Therefore, attached ball is not null now once this game object is into the attached ball. And now, and here we are instantiating a ball prefab right here in a certain position right here of x 0, y 40 and z 40, and quaternion dot identity, which means that is as a game object. And here, so that it recognizes that it is a game object, we needed this piece of code as game object. And now the ball prefab will be virtually in the attached ball. Now we need to add a code so that when the attached ball is there and the user presses space, the ball will go upwards. So that will involve the rigid body to have a force added to it, and therefore the ball will go upwards. So let's go in the update function, go out of this if, and let's make another if. So if attached ball, so if there is a ball attached and it is not null, make this code. So ball rigid body equals attached ball dot rigid body. So the rigid body of the ball will be null in this case because attached ball is not moving. Therefore the rigid body will be the same as nothing properly, but there will be a rigid body, and afterwards we will add a force to that rigid body, therefore it will be moved. So ball rigid body equals attached ball dot rigid body. Ball rigid body dot position. Now in this line we are going to put the ball into a certain place, and we want it approximately above the pedal, exactly above the pedal. Therefore we are going to create a new vector tree again, transform dot position plus new vector tree, and we are going to place it where we want. 0, I'm going to place it 0 on the X, right in the center, 5.5 on the Y, so that it is 5.5 right above the pedal and not exactly in the middle of the pedal, so that you make it more realistic, and 0 on the Z always, and save. Now if the user presses enter, presses space, get button down, and this space is referred to as jump, make this code. So ball rigid body dot is kinematic equals false. Ball rigid body, this is most important part, dot add force, a force will be added, and it will be added according to our needs. So we want it to go upwards. Therefore here it is telling us force as unity engine dot vector tree. Therefore this means that we have to input 3 values, the X, Y, and Z again. Therefore we don't need any force on the X, we need the speed of the ball as the Y. Therefore we are going to input ball speed here, and on the Z obviously always 0, and save. The last thing is to make the attached ball null again, so that the process can be repeated again, and this object can be later on put again into the attached ball. That's why. So now the last thing to do is to call the spawn ball function. So in the start we are going to call it at the beginning of the game, therefore you just write spawn ball, open and close, and it is called. Now I think I have unchecked it, but if it doesn't work, you need to go on the ball, go on rigid body, and I think I left it like this in the first tutorial. Untick that, use gravity, because we are going to give it the speed and it doesn't need gravity, and that should work. So save, let's see. So the ball is right there. As you can see, if I move it, the ball is attached to it, and if I press space, the ball is shot upwards. And obviously with the material that we added in the first tutorial, it will bounce again and again. Always with the same speed, as it doesn't have gravity, and we inputted the speed as 4250. So that is done as well. Now the last thing about the pedal is to add the sound, which is a very small thing and easy as well. And the most difficult part in all the game, because it is a bit tricky to understand, the part where the ball, if it hits like this, the edge of the pedal, it will go a bit like this, not instead of going upwards. So to do that, first we need to create a function that is reserved, which means that it is done by default by Unity, and it can be used. So it is called on collision enter, which is triggered always when a game object or something else hits the current game object in which this function is in. Therefore, this function is in the pedal, therefore this will trigger once something hits the pedal. This variable right here is a parameter, and this will hold the game object that will hit the pedal, not the pedal that will hit the pedal. So audio, this line will be the sound that will be added once something hits the pedal. So audio dot play one shot, because the ball, for example, hits only once the pedal, obviously once, not once in the game, but just once and bounces back, that's all. So play one shot, and in the brackets pedal sound, 0.5. The 0.5 is just in case for the length of the clip. So play one shot, pedal sound, or whatever the variable is called right here, and 0.5. So the most tricky part. So let's make a for each loop. So for each, this will be a for loop that will analyze each contact point in the pedal, and according to where the ball hits, it will have a small angle so that it will hit the other blocks on the side. So for var contact of type contact point, so contact of type contact point in call.contacts. So each contact point in the pedal, in the contacts of the colliding object right here, we are going to execute a code. Hope you are understanding it. This is my first time doing a video about coding, so I hope this will help. So for each contact of type contact point in call.contacts, if contact dot this collider equals collider, which means if the contact of type contact point is equal to the collider of the pedal. Right here I'm going to add a comment. This is the pedal's contact point, and now we are going to add a small code so that a small angle will be given. So var ball angle float equals contact dot point dot x, because it is on the x axis of the pedal, minus transform dot position dot x. Finish. Then the last line, contact dot other collider dot rigid body dot add force, and now we are going to add a small force on the x-axis so that the ball moves, has a bit of an angle and moves to the left or right according to where it hits. So 100, let's make a bit of a force, times the ball angle, sorry, not 8, times ball angle 0, because of the y we don't have to add the force on the y, and obviously not on the z, and close. So now we should have the sound playing of this because of this line, and the contact points working. So let's check it out. Play. Shoot it. We let it. Okay. There's a small error I forgot to do. So to make the sound play, we need an audio source in the pedal. So we just go at component here in the inspector, or component audio, and choose audio source. Important. Just drag, just untick play on awake and drag the pedal sound right here, and it should tell you this is a 2D sound. Save, and it should play. So as you can see, I hit it on the edge and the ball moved at an angle. Right there. So, and obviously the sound is playing once the ball hits the pedal. So I think that's it for this tutorial. We managed to do all the things necessary for the pedal. Now in the third tutorial we are going to tackle some things about the ball. Hope you enjoyed this tutorial. See you in the next. Don't forget to like and subscribe. Thanks again.